Today we're going to talk about graphs of the circular functions, and more specifically, graphs of the sine curve and the cosine curve. The sine function, f of x equals sine of x. We're going to talk about how to graph the sine function on a coordinate plane. Remember that our domain is all of the x values, all of these that we're plugging into the function, and the range is all the y values, or all the output. When you plug in the x value and you find the sine of that, that gives you the output. So the input is the x value, which is domain, and the sine of x is your output, which gives you your range. So think about the unit circle and all of the angles involved in the unit circle. Our angle measures are what is being input into the function. And the sine values, those y values on the circle, are what's the output of our function. So when we go around the circle, we start at 0, and we go to pi over 6 and pi over 4 and pi over 3. Now keep in mind there are lots of little angles in between all of these. These are just the big ones that we put on the unit circle from those special triangles, the 30, 60, 90, when we're talking about degrees. And then we come up to the 90 degree, or the y-axis, which is pi over 2 in radians. And then we come back down to pi. So that completes our second quadrant, and then we go to 3 pi over 2, and there's our third quadrant, and then we come back up to 2 pi, and that makes one whole circle. And you can keep going around this circle as many times as you want. Remember that we also have negative angle measures, so our angle measures are limitless, and that is why our domain is from negative infinity to positive infinity, because they go on forever in both directions. See, our graph will go on forever in both directions. And there is no possible x value that cannot be put onto this graph. Now our range is a little bit different. If you look at all the y values, and if you remember back when we talked about what possible outcomes we have for sine, we have 0, 1, half, pi over 2, or I'm sorry, square root of 2 over 2, square root of 3 over 2, and then 1. And then it comes back down to 0, and then it comes down to -1, and then it comes back up to 0. So our minimum is -1, and our maximum is +1, which you can see in the range here. And then if you look at the graph of the sine curve, you'll notice up here you have your maximum, which is 1. You have another maximum up here, which is 1. And then your minimum is -1. The lowest point on the graph is -1. So that's why our range is from -1 to 1. Now notice we have brackets here because they include -1 and 1. Whereas here we have parentheses because there is no end to infinity, so it doesn't include a number called infinity because infinity just goes on forever. Okay, so then you can see on our table here where you have your x and y coordinates, and remember the x's came from the angle measures on the unit circle, and the y values came from the sine values on the unit circle, which are the y values on the unit circle. And then you can graph those. So here we have our 0, 0, and then it comes up to pi over 6, 1/2, pi over 4, square root of 2 over 2, pi over 3, square root of 3 over 2, and then pi over 2, 1, and then it comes down to 1. And you can see these are symmetric. If I were to draw a line here, then these would be equidistant from that line. So the same y values are equidistant from that line of symmetry. Hopefully you remember that from geometry. So you come back down here to pi 0, and then you keep going, and you get to 3 pi over 2, -1, and then you come back up here to 2 pi 0. And again, you have another line of symmetry. Okay, so all of these curves are symmetric with the maximum and minimum as your line of symmetry. Okay, so if it's above the x-axis, you have your line of symmetry at the maximum. So you could fold this on top of itself and get those. And then if you're below the x-axis, then your line of symmetry is right here, with your minimum, going through your minimum. Okay? You'll notice that your cosine curve is very similar to your sine curve. You have the same domain, you have the same range because your maximum is 1, your minimum is -1. It goes on forever in both directions. But now we're looking, when we look at the unit circle, we're looking at all of the cosine values as our y's. Our x values are still the angle measures, but our y values now come from the cosine of that angle, which is the x coordinate on the unit circle. So now our y values on this graph are the x values on the unit circle. So when we have an angle measure 0, our x value was 1, so that becomes our y value on this graph. So we plot the point 0, 1. Then when we had pi over 6 as our angle measure, our cosine value was square root of 3 over 2. So then we graph that. Then when our angle measure was pi over 4, our cosine value was square root of 2 over 2, so we go graph that. And when our angle measure was pi over 3, our cosine value was 1/2, so we graph that. And then when it was pi over 2, our cosine was 0. And when the angle is pi, our cosine is -1, so we're right over there. When our angle measure was 3 pi over 2, our cosine was 0, so we graph that point. And then when our angle measure was 2 pi, we're right back to 1. Okay, so this is the graph of one complete unit circle. Notice it also has those lines of symmetry that the sine curve had. They're just in different places. It has all the same values as the sine curve, they're just in different places. Now let's talk about the period of a function. The period is from start to finish one full upward curve and downward curve of the graph. So if we start here at 0, 0, and we go up to the maximum, and then we come down, we cross the x-axis, come down to the minimum, and come back up to 0, that is one full period. Okay? So for the y equals sine, one full period is here from 0 to 2 pi. So our period is called 2 pi because it takes from 0 to 2 pi for it to make one full upward and downward curve. So whenever we have a coefficient of sine, coefficient of the sine, that's called the amplitude. And that's basically going to take this normal sine curve and it's going to stretch it vertically. Okay, so when our normal sine curve's maximum is 1, you're going to take your a value and multiply the 1 by the a to give you that stretch. So when we have a 2 in front of the sine, it becomes the maximum becomes 2 and the minimum becomes -2. You're taking the whole curve and stretching it vertically by a factor of whatever that number is. Okay, so that tells you the vertical stretch. If this number is negative, you're still stretching upward if it's a whole number, or if it's a number greater than 1. But if it's negative, it'll just flip it downwards. And we'll talk more about that later. All right, now let's take a look and see what happens when we have a coefficient of x. So in this case, we have b times x, instead of having a coefficient of the sine value. Remember that in the normal sine curve, one period is 2 pi. So we start at 0, we come up to our maximum, cross the x-axis again, come down to our minimum, and come back up to where we started. So that's one full period. So 2 pi is one full period. But when we have sine of 2x, let's look and see what happens to our period there. We start at 0, 0 still, come up to our maximum a lot faster than we do for the regular sine curve, come back down and cross the x-axis, come down to our minimum, and come back up to where we started. So now what is our period? Pi. So our period is now half of the original sine curve. What that b does is it scrunches horizontally the graph and makes it either tighter or wider depending on what that value is. Now let's take a look and see why that happens. So in the normal sine curve, our period is from 0 to 2 pi. So now what we want to do is find what our period is going to be for 2x. So what we need to do is say 0 is less than or equal to 2x is less than or equal to 2 pi because the normal period is from 0 to 2 pi. So now we just need to solve for x here. So we have 0 divided by 2 is 0. 2x divided by 2 is just x. And then 2 pi divided by 2 is pi. So you can see that our new period is from 0 to pi. And look at this, 0 to pi. So that's how we get the period based on what the coefficient of the x is going to be. And when you come into class, we'll talk more about how we can find the ordered pairs to graph to create these sine curves.